Hello everyone, so today we are going to go over what a function is. We're going to go over how do we identify if a graph represents a function and how to evaluate a function in function notation. So here's a definition you have on your paper. A function is a relation between a given set of elements such that each element in the domain, there exists one element in the range. Now, that's a pretty intense definition. It's very mathematical, has a lot of vocab words that we really haven't gotten deep into. But we're going to look at a slightly nicer definition, which is a student-friendly definition. So it's a relationship pretty much between two things. And the relationship is such that for every input value, there is exactly one output. So if we look at the left, we have kind of a visual. Think of a machine like a washing machine. You put in dirty clothes. What do you get out of it? You get clean clothes. So the function of the machine is to clean your clothes. Just like a dishwasher or a microwave. Now, its function would be to warm up your food. You put in cold food, warm food comes out. So think of this as that. So a function would be something that you take an input value, and you always get that same output value for that specific input value. So you are not going to put in dirty clothes into a washing machine and get something besides clean clothes. So we're going to go ahead and look at some examples of this. So let's look at some examples of that happening. So you guys have some on your paper. So we have 3 examples on the left of something that is a function and 3 non-examples. And we're going to come back to them in a little bit. So let's first go into what is function notation. And this is going to kind of relate to yesterday's lesson, which was on us evaluating or solving for a given value based on x equals 7 and y equals 9 or something like that. So let's go ahead and get our definitions down. So function notation, it goes for an equation that is a function may be expressed using this type of notation. So what it looks like is, here's your first blank. If I put something like f with a little parenthesis, the letter x inside, and another parenthesis. So this does not mean f times x. The way we read this in mathematics, we read it as f of x. So f of x. It does not mean f times x. So in this case, the parentheses don't indicate multiplication. And it represents the variable x. So in this case, we have the f, which represents f for function. We can use any letter you want, and we're going to be, I'm sorry, it's not x. Sorry, wrong one. It represents y. So instead of us having y equals 2x plus 3, we can have f of x equals 2x plus 3. So functions can be named using any letter. Again, F is pretty common. G and H are also common. So those are the 3 common letters. Just like when we have variables, we like to use X, Y, and Z a lot. For functions, we like to use the letter F for function, G and H as well. So let's say we have the equation y equals 2x plus 6. I'm going to rewrite this as a function. So all I need to do is take my y value and just replace it for f of x. So I'm going to call it f of x equals 2x plus 6. So all I changed was the y value for f of x. That's pretty much it. So functions represent the y value of an equation. So if you're asked to find f of 3, it means that the variable x is the value of 3. So in this case specifically, x would be replaced, or it's replaced, with the value of 3. So f of 3, instead of f of x here, notice that the 3 is in the spot of the x value. So f of x, or f of 3 in this case, would be replaced with the value of 3. The x changes or substitutes a 3. So instead of me saying evaluate the function f at x is equal to 3, I can just say f of 3, which is a lot faster. So let me just show you. I can say f of 3, which means plug in a 3, or I can say evaluate f of x when x is equal to 3. So again, looking at the 2 sides, which one's faster? Obviously the one on the left. The one on the left says what I wrote out on the right. So it means plug in the number 3 in the function. That's pretty much what it says. So let's go ahead and see how that works. So let's look at example number 1. We have a function f of x equals 4x plus 8, and we are asked to evaluate 3 different values. So we're going to go ahead and plug in the number 2, figure it out, plug in the number 6, figure it out, and plug in the number -4 and figure that out. Let's go ahead and start that. So we're going to do f of 2, which means all the x's become 2. So 4 times 2 plus 8, which gives us 8 plus 8, which gives us 16. So f of 2 is equal to 16. Let's try the next one. So now we have f of 6. So let's go ahead and do f of 6, which tells us 4 times 6, so this time we're substituting a 6, plus 8. 4 times 6 is 24, plus 8, and 24 plus 8 is 32. So we've evaluated at 2, at 6, and now we're going to go ahead and do one more. We're now going to evaluate at 4. That's negative. So now f of negative 4. We're going to go ahead and plug in the number negative 4. So 4 times negative 4 plus 8. So 4 times 4 is 16, but one of the 4's is negative, so we get negative 16 plus 8. Opposite subtract, so we're going to get negative 8. And I've just evaluated the function f of x for 3 values, 2, 6, and negative 4. I'm going to go ahead and clear this out, and we're going to go ahead and do the one on the right. All right, so we have f of x is 3x squared plus 1. This time we are going to go ahead and plug in the numbers 3, the numbers 10, and the numbers, whoops. All right, here we go again. So we're going to substitute the numbers 3, 10, and 5. So let's go ahead and get started with that. So we have f of 3, which we would plug in the number 3. So we have 3 squared minus 1. Remember, exponents always go first, so we have 3 times 9, because 3 times 3 is 9. We have 27 minus 1, which gives us 26. That's our first one. Let's go ahead and do the next one. Let's go ahead and plug in 10. So f of 10 is 3, 10 squared minus 1. Then we get 3 times 100, exponents go first, minus 1. 3 times 100 is 300, minus 1, which gives us 299. All right, last one I'm going to do here on the left, so I won't have to clear the screen yet. Let's go ahead and do f of 5, negative 5. We're going to have 3 times negative 5 squared minus 1, which gives us 3 times positive 25, because a negative 5 times another negative is positive. 3 times 25 is 75. Take away 1, which gives us 74. So it's pretty much just plugging in and solving, just what we did yesterday, but the only difference is we are doing it in function notation. The f of whatever's in there tells you what to plug in instead of me separately saying x equals the number. All right, let's continue with the second piece of our lesson, which is how to tell by looking at a graph if it's a function or not a function. Not any old graph is going to be a function. So certain graphs do not fit the requirements to be a function. That goes back to the definition: for every input, there is one output. So let's go ahead and look at the 3 examples on the right. So the first one is a function, the second one is a function, and the third one is not a function. So the graphs are the blue lines, the red line that's going up and down, which is this one here. This line tells me whether it's a function or not. So let's go ahead and see the requirement to decide if something is a function or not. So a graph is a function if it passes something called the vertical line test. So what that means is if I draw a vertical line, and if at any point this vertical line hits the graph more than once, it is not a function. So again, pass if a vertical line crosses the graph once, only one time. It fails if the line crosses a graph more than once. So looking at our first one, it only hits the graph one time. Looking at our second, I draw the vertical line. It only hits the graph once. The third one, here's the vertical line. We can see that it hits the graph 1, 2, and 3 times. Therefore, it fails the vertical line test. You can draw the vertical line anywhere, but if there's in there's any place where you can draw that line and it hits more than once, it fails. Some of you guys may be asking, well, what if you drew the line over here? It only hits it once. Yes, that's true. That piece of the graph technically is a function if you just look at that piece. But if there's anywhere else you can put that line and it hits it more than once, it fails the vertical line test. So let's go ahead and look at some examples and us decide if something is a function or not. So here we have 8 graphs to look at. And we're going to go through all of them and decide, does it pass the vertical line test? So I'm going to go ahead and start drawing my little vertical lines. So I'm going to go ahead and say, all right, I'm going to draw a line. Let's say, is there any way I can draw my line that hits it more than once? I can draw it there. I can draw it here. No matter where I draw this vertical line, it only hits it ever one time. So there's nowhere that this straight line is going to not fail the vertical line test. So this one's going to be a yes, it's a function. Let's look at this next one. Can I draw a line somewhere that's vertical that's going to hit the circle more than twice? And pretty much your answer should be yes, I can draw this line. Let's say right here. It hits it once, and it hits it here once and twice. So this one is not a function. So again, first one's a function, second one's not a function because it hits it twice, it fails the vertical line test. Next one, anywhere I can draw this vertical line that hits it more than once. As I draw a whole bunch of these, do you see that every time it only hits it one time? So there's nowhere that it hits it more than one time. So this is a function. Next one, can I draw a line vertical somewhere? Let's say right here. It fails the vertical line test, so this is not a function. Look at the next one. Try the next 3 on your own, and I'll come back and go over the answers. Just pause it real quick. All right, now that you've gotten some answers, this one you should have gotten, yes, it's a function. There's nowhere to put that line other than somewhere where it hits it. Even over here, there's no graph there, but that doesn't make a difference in terms of it being a function or not, if you can draw a vertical line that hits nothing. All right, next one, you should have gotten a yes. It's a function. Next one, you should have gotten a no. Here, it fails the vertical line test. And here's another spot you may not have thought of. You could have also put the line here, and it hits this right here many, 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 many times right here. So here it fails the vertical line test many times over, because in this whole area, it's hitting the graph. So this right here is definitely not a function. And the last one, we have this curve. Did you get yes or no? And the answer is yes, it's a function. So it may seem like in this little portion it's going to hit more than once, but it technically doesn't. This is called an exponential function, and it forever moves to the right. So it's really hard to tell on this one, but yes, it only hits it once, even as you get closer to the right, even though it's technically visually hard to see that. So just be very careful with that kind. Hint for your quiz on Friday. But again, this is the general idea. Let's go ahead and do a few more, just quick ones. Let's see, let's find it. There we go. All right, let's see if we have the vertical line test here. So this one, vertical line test, is it a function? And this one would be, yes, never hits it more than once. As you can see, my line moving across. Next one, is it a function? And as my vertical line moves across, it only hits it ever once. All right, let's look at the next one. I think we have this one in our notes, so let's go with this one. We should see that it's always hitting it twice as we were to move that line across. So in this case, this is not a function. Hits it twice, top and bottom. Let's look at the next one. Again, this is very similar to the previous one. I'll skip that one. Let's look at this next line. This is function or not a function? Answer is function. Next one, function or not a function? Not a function, and vertical lines will hit it 3 times. This next one, function or not a function? It's a function. It will never hit it more than once. This next one looks like a Z shape, function or not a function? So this one is not a function. You will hit it 3 times in that middle section. This next one, function or not a function? Should have said function. It will never hit more than once. This one right here, function or not a function? And this one is not a function. If you draw your line down here, it's going to hit here over and over and over again. All right, let's go to the next one. And that was pretty much it, actually. So go ahead and get started on your practice, and good luck.